So I'm going to draw an electrochemical cell now, alright? And then do an example with some half reaction. So the two electrodes. So remember that you have to practice to draw this cell, because you're going to be required to draw it in the exam, alright? So some people might put a bulb here. It's going to be the anode. Alright, and remember as I said before, electrons move in this direction. Right? So for those who were not on time, this is what the mnemonic I was using, that the movements of electrons in an electrochemical cell is as easy as A, B, C, where A is for the anode, the B is for the battery, and the C is for the cathode. Right? So the electrons are moving over in this direction. The battery is now pushing the electrons in this direction, and this means that this is going to be negatively charged, and this is going to be positively charged. The electrode, that is, right? So this is going to be plus, plus, plus. Following? Now, say for example we use some table salt at home. Alright, let us use like a molten solution first, right? Say for example we have lead bromide liquid. So this is so the electrolyte here, molten PbBr2. So it's a liquid state here. So we don't add any water to it. It's just the heat we supply here. So this will be like heat. So only ions we'll have in solution is Pb2 plus, Br minus. Clear? No. Right, Mr. Harding? Now remember that we're only going to have Pb2 plus and Br minus. Now remember that we did not dissolve it in solution. So this is the electrolysis. Lead bromide liquid. Alright? No. So at the anode, so this is how you have to do it in the exam. So at the anode, they want to know which reaction is taking place. So the anode is positive, so which ions will attract to the anode here? The Br minus or the lead?
To the anode?
Yes.
To the anode?
Yes.
The lead.
No,
it's the opposite. Br. Remember that opposite will attract. So if here is positive, is the negative ions are going to go to the electrode. Alright? So at the anode, it's going to be Br minus liquid. I'm going to lose the electrons, produce Br2. It's going to be gas in this case because it's so hot. Plus 2 electrons. So to balance it, will have to be 2 here. Clear? Well, at the cathode, these are half equations that you have to remember. So we call these half. It's going to be Pb2 plus liquid plus electrons, 2 electrons, Pb solid. So the half equation that is taking place there. Right? Now remember that in this case, we only have Br minus anions and Pb2 plus cations, right? So what's going to take place here is that at the anode, you'll have alright, so let us go there. or let's go sodium chloride, aqueous. And we say dilute. Now when we have the halides ions of chloride, bromide, iodine, we have to state whether it's concentrated or dilute, right? Sodium chloride using example graphite. Graphite. I'm going to use graphite here as well. It could be platinum as well, alright? So in this solution we're going to have ions in solution, Na plus, H plus, Cl minus, OH minus. Right? So those are the possible ions that can react at the anode or the cathode. Remember that this electrode is positive, this is negative. No. So at the anode, we have it's a positive electrode. So we have two possible ions that can be discharged here. What are those two ions, Mr. Hardy? Put you on the spot. Which two ions can react at the anode? The anode is positively charged, and these are the four ions we have in solution. Which two ions are possible to react here?
Chloride and hydroxide.
Good. Alright, remember that it's positive. So at least you're following. Alright, so alright now. So we have two possibilities that can take place. So these are possible anode reaction, right? No. I gave you a set of rules, So I gave you 3 rules to know which electrode will discharge at the anode. The first one was whether the electrode is active or inert. The second one was the concentration. If it's a halide, the concentration. And the third one was the position in the electrochemical series, right? So first question, is the electrode active or inert? It's inert, right? So it simply means that electrode will not take part in the electrochemical reaction. So the next question would be, is the solution contains halide ions? Yes. Is it concentrated or dilute? It's dilute, so it simply means that if it's dilute, it simply means that it will not take first preference to react. Then it's the electrochemical series of the anions is going to determine which anion is going to react at the anode, right? So the third step would be now the electrochemical series. Is chloride or hydroxide lower in the electrochemical series? Hydroxide is low, right? So therefore that's how we would derive the answer here, that is the hydroxide ions is going to react at the anode, alright? And for the anode, it is OH minus. This is an equation that you have to write a lot to remember, right? Because it's very complicated and unusual, right? And what we're going to observe here is that we're going to see gas bubbles coming off at the anode. Here? So here will be gas bubbles coming off here. Sorry, the anode. Bubbles, which is O2 gas. Following, because it's a gas that is produced that will just go, right? Alright, now the cathode. Which reaction will take place at the cathode? So the reaction is the electrodes are inert, and remember that in this case it's mainly the electrochemical series that is gonna, to be honest, for the cathode reaction, it's just mainly an electrochemical series issue of the cations. Alright, it's just the anions and the anode tend to be more complicated. For the cathode, you just need to remember the electrochemical series for the cations. And remember, as I said before, it's like the period 1, period 2 for group 1 and 2. No, the period 3, so it would be the potassium and the calcium, then the sodium and the magnesium, then the aluminum, then the transition metals. And hydrogen is just above copper and silver. So you can just use those little things to remember. Alright? So in this case, the hydrogen is going to be way lower than the sodium, because the sodium is about the third in terms of ion, cation. You remember the series I wrote here for the cations? Yes. It's the potassium, calcium, sodium, then magnesium, right? And hydrogen will be low down, about third to the bottom, right? Only copper and silver is below the hydrogen, right? That simply means here it's going to be H plus, AQ. I'm going to pick up the electron. Remember that the cathode will supply the electrons. That's one electron to produce H2 gas. Right? So to balance, this is going to be 2 and 2. Clear? Now remember that a hydrogen atom will not just exist by itself. It will form the atomic molecule. So all the halogens, when they form the atom, they will just combine together to form the atomic molecule. Likewise, hydrogen will do the same. Alright? So those are the reactions that are taking place there. Alright? Now, they will ask some other questions in the exam, like what would you observe here? Like, you'll see gas bubbles coming out from the cathode as well. Alright? But this is now going to be hydrogen gas. Right, so the observation will be gas bubbles coming off here, gas bubbles coming off here. Okay? Now, what would happen to the concentration of the sodium chloride? And that's another question that they could ask. What would happen to the concentration of this sodium chloride solution?
Become more concentrated, say.
Good. Why?
So because it's receiving. I'm not sure why.
Because the process is basically removing water. Because as you can see, the hydroxide and the hydrogen ion from the water, which is the solvent, is being removed as gas bubbles. Because the hydroxide is going to be removed as oxygen gas, the proton is going to remove as hydrogen gas. So the solution is going to become more concentrated. So the sodium chloride solution is going to become more concentrated. Clear? Chemistry is use of knowledge to test for the exam. It's not just knowledge, alright? Alright, so we just did dilute sodium chloride. We're going to do concentrated sodium chloride, alright? Remember that I'm going to draw the diagram out slightly different just to capture how they would. Right? No, what happens is that they will have a beaker like this, but instead, no, not really a beaker, but like a little cylinder like without any end, right? And then they're going to put a little rubber bomb here. So this is like a rubber. Right? Right, so we're gonna keep over here as the anode as usual. Over here as the cathode. That's negative, that's positive, alright? The battery. No. Normally they put a test tube here. So this is, it can measure the volume of gas that's produced, alright? Remember, I'm not really good at the diagrams, alright? But it will look something like this. You can check it out, alright? So here, it's concentrated sodium chloride. No. So here, oh, that's right. There's some space to the right. The half reactor. It's a little lower. Alright, so anode, cathode, reaction, right? Alright, so for the anode is the positive. That anode is positive, cathode is negative, right? Remember that the electrons move like A, B, C, so they're moving in this direction. Because sometimes the exam will ask which direction to label the diagram to show which direction the electrons move. Alright? So it's always going to move from the anode to the cathode through the battery. Alright? Now, if it's concentrated sodium chloride, it simply means that the anode is going to attract the anions, right? So the anions that are possible over here would be the Cl minus and OH minus, right? Now, the electrodes are inert. Make a note that inert electrode, or better, we can just put graphite here. We're going to use graphite on both sides, right? Now, so the reaction that is taking place at the anode, the possibility at the anode is chloride or hydroxide, right? But remember that in this case it's concentrated solution of a halide ion. So the halide ion is going to discharge in preference of the hydroxide ion because it's concentrated sodium chloride. So remember that if it is chloride, bromide, or iodide, so if they use sodium bromide, magnesium bromide, potassium chloride, potassium bromide, and it's concentrated, it's the halide ion that is going to react at the anode. Right? So here, now the reaction here is Cl minus AQ is going to produce Cl2 gas plus 2 electrons. Remember I have to balance it because we have the chlorine here, it's 2 moles of chloride ion is going to end up required to produce 1 mole of chlorine gas. So we have to balance it that way. Alright, so it's 2 moles of electrons going to pass. Alright? So here it simply means that at the anode we're going to have like gas bubbles being formed. Because remember that initially we would have the sodium chloride solution all the way in the test tube as well. So as the gas is formed, it's going to displace the electrolyte. So here is going to be Cl2 gas. It's going to displace it because the gas is going to form here and it's going to go up. So you have to be familiar with cells which looks like this when gas is concerned, right? And remember that if this is graduate, if this is have the units on it, then we can measure the volume of gas that is produced. Alright? And that's going to become very essential when we go into the calculations afterwards. Alright? Now, which reaction is going to take place at the cathode? So here we have the sodium plus or hydrogen plus ions for the cathode. Which ion is going to go there? The sodium or the hydrogen?
Sodium.
Why?
Because it's higher than hydrogen.
No, but it's the one that is lower normally goes there.
So, one is
The principle is the ion that is lower in the electrochemical series normally reacts, you know. Remember that this is electrochemistry and it's actually the reverse process. So in electrochemistry, the iron that is lower in the electrochemical series is the one that will take place in the reaction at the anode or cathode. Alright? So in this case, hydrogen is lower than sodium. Way lower, because sodium is about the third from top. Hydrogen is third to last.
So I use the chloride.
Because it's the rule that states that for the anode or the anions, we have to first ask if it is an active or inert anode, and we also have to ask the second question whether it is a concentrated or dilute solution of a halide ion. Because it's a concentrated solution of a halide ion, which is chloride, then it's going to discharge in preference of the hydroxide, even though it is lower in the reactivity series, because it is it's like a stronger factor to determine which ion is discharged. So the concentration factor for a halide is stronger than the electrochemical series position. I can't explain it any better. Alright, you just have to read it. Alright? So here we have for the cathode it's gonna be H plus aqueous plus 2 electrons produce hydrogen gas. So hydrogen gas is gonna be produced here. Alright, so what's going to happen here is that gas bubbles is going to be produced in both of the cylinders, right? And it's going to actually be in a 1-to-1 ratio based on the half equations, because it's 2 moles of electron discharge 1 mole of the chlorine gas over here, and it's 2 moles of electron discharge 1 mole of chlorine gas over there. Alright?